As we study systems of equations, we will study 3 different methods for solving systems of equations. We'll look at the graphing method, the substitution method, and the addition method, also sometimes called the elimination method. First, graphing. When graphing a system, the intersection point is the solution. It's the only spot where both equations are true. Here are the steps to solve by graphing. First, get all the equations into y equals mx plus b or slope-intercept form. Then we can graph them. Second, graph your equations. Third, find the intersection point. And fourth, write as an ordered pair. So the first example, x minus 2y equals 2. This right now is in general form. We need to get it into slope-intercept form so we can graph more easily. I will use my algebra to get y by itself, just like we did last chapter. Negative divided by a negative becomes a positive. This can be 1, so this is like 1/2 x. 2 divided by negative 2 is a negative 1. So let's graph this. My b number is negative 1. My m number is 1/2. That means I will go up 1, right 2. Continue my pattern backwards. If you need a review of graphing, go back to one of the previous modules for reviewing on graphing using slope-intercept form or graphing from standard form. Next equation, x plus y equals 5. Again, this is in general form. I need it in slope-intercept form. I need to solve for y. This one's faster. So we'll graph it. My b number, my y-intercept is 5. My m number is negative 1. You might know that a b number of negative 1 means that I will go downhill at a 45-degree angle, so you could just draw that in. Or you can make your m number into a fraction by putting a 1 under it. This means the rise is going to be negative 1, or it goes down 1, and right 1. We're looking for the intersection point of these two lines. So what's my answer? My intersection point is what I'm looking for. The intersection point has an x-coordinate of 4 and a y-coordinate of 1. So that's the answer. Again, a solution to a system of equations is an ordered pair with an x and a y coordinate. Let's look at this a little bit more closely. When I graph this line, x plus y equals 5, I'm graphing all the solutions. Anything that falls on this line will be a solution to this equation. When I graph this line, x minus 2y equals 2, any ordered pair on this line is a solution to that equation. So the solution to the system is the only spot that's on both lines. The only spot that satisfies this line and this line. To check this, take each of your equations and sub in your point. This is the x, this is the y. So 4 minus 2 times 1 is equal to 2. Yep, 4 minus 2 is 2, so that works. Now let's take our other equation. X plus y equals 5. Well, our x is 4 and our y is 1. 4 plus 1 equals 5. Yep, this checks. This point satisfies or is a solution to both of these two equations. Solve by the graphing method. Again, I'm going to graph my first line, graph my second line, and find the intersection point. The ordered pair that describes that intersection point will be the solution to my system of equations. We'll start by changing this equation from general form into slope-intercept form so that we can graph it. Negative 1/3 x plus 1. So let's graph it. The b number is 1. My m number is negative 1/3. Rise over run, so my rise is negative 1. I'll go down 1, right 3. Same pattern backwards. Next line. Again, change from general form to slope-intercept form. Get the y by itself so that you can graph more easily using the slope and the y-intercept. The y-intercept, the b number is 5. Make a dot on the y-axis at 5. My m number is 1. You may know that that means a 45-degree angle going uphill, so you could draw that in. Or your m number is 1. Make that into a fraction. That's going to be up 1, right 1. For more practice on graphing lines, go back a couple modules. We practice graphing lines a lot. When you graph a system of equations, you will usually find that your two lines will cross in one place, and that is the only place where both equations are true. So, to find the answer, you find the x-coordinate and y-coordinate of that point. That's our solution. To check, you can plug these numbers in for x and y into your two original equations. That will check your answer. Solve this system of equations by the graphing method. Since these are in standard form, I must change them into slope-intercept form in order to graph more easily. Don't forget that the negative comes down with the y. To undo that negative, we'll divide each term by negative 1. That will change the sign of every term. So there's our linear equation in slope-intercept form. Now let's graph. 1 is the b number. The m number is 2. Make it into a fraction. That means up 2, right 1. Same pattern backwards. Second line. Again, change from standard form into slope-intercept form. I'm going to change that 7/2 into 3.5. So I have a better idea of where my B number will be. That B number at 3.5 will be right here. There's my M number, so my slope pattern will be down 1, right 2. So from there, I'll go down from 3.5 to 2.5, and then right 2. Down 1, right 2. Same pattern backwards. So any spot on the purple line is a solution to the purple equation. Any point on the blue line is a solution to the blue equation. The only point that is a solution to both equations is the point that is on both equations, the intersection point. X coordinate of 1, y coordinate of 3. And that's our answer. Ordered pairs are how we write the solution to a system of two linear equations.